Hello friends, today's topic is SF and BM, that is shear force and bending moment. Okay, so in this topic we have uh, two types of problems. Okay, one is beam type and box type. Okay, for the moment we'll just only consider doing the beam type one. Okay, so let's delete this box type. Okay, so for beam types problem also we have three different categories, like a simple beam, okay, and a beam with support, okay, and a beam with load on it. Okay, so this support beam with support, this is also a different type. Okay, like simply support. Okay, in simply support, suppose this is a beam, there is just two supports under the beam. This is simply support beam. Okay, another one is fixed support. Okay, in the fixed support, what we have here is one beam will be there. That beam is permanently fixed to any structure on both the ends. Okay, that is fixed support. Okay, another support we have here is cantilever. Okay, in cantilever beam, there are only one end of the beam is permanently fixed to any support. Okay, so that is called a cantilever beam. Okay, and this is about the support of the beams, and we will be talking about, and I will be discussing again the load of the beam. Okay, so depending upon the load acting on the beam, there are two types of loads. One is point load. Point load. In point load, what happened if this is a beam support with supporters? Okay, some weight will be or load will be acting at a particular point. Okay, so that type of beam and load arrangement is called point load arrangement. Okay, another thing is uniform distribution of load. Okay, in uniform distribution, suppose this is beam and the supports of the beam, there is load on top of the beam, but this load is uniformly distributed along the entire length of the beam. Okay, so that kind of beam is called a uniformly distributed load beam. Okay, so these are the uh, terms you should understand when we proceed further. Okay, what is simply support, what is fixed support, cantilever, point load, and uniform distribution of load. Okay, now we will be discussing more about the beams and the load acting on it. Okay, so suppose this is a beam. Okay, beam has supports like this on both the end. Okay, so the length of, let's assume the length of the beam is L, L meters or L feet, whatever. Okay, so okay, and let's assume there is a unit load acting at the center of the beam. Okay, okay, so let's give the name P for that unit load. Okay, so since this is P, okay, now we have to draw a simple diagram for this, for the calculation purpose. Okay, so that diagram is free body plan. Okay, we will be drawing free body plan. Okay, in free body plan we will give these 2 points also a name. Okay, let's assume A and B. Okay, so this is A, this is B. Okay, and the weight is acting at a point. Okay, let's give a name C. Okay, so when a weight is acting downwards, there must, since the beam is this is beam. Okay, beam is supporting as resting on these two supporters, so the weight acting on the beam will be distributed between both the supports. Okay, so for when we moving forward, these forces, okay, there will be forces acting on the beam. Okay, for one force is the force acting vertically downwards, another forces are which is acting at the support, which is acting upwards to support the beam. Okay, so the force acting at the supports is called reactive force. Why it is called reactive force? Because this force is acting due to the reaction of any load applying on the beam. Okay, so this force is called reactive force. Okay, so in a free body diagram, the reactive forces is acting on two ends. Okay, at point A and point B. Okay, so the reactive forces will be given a name. Reactive short forms like R. Okay, that is reactive force. Okay, so reactive force is acting at the point A. Okay, RA. Okay, similarly there is another reactive force acting at the point B, that is RB. So these reactive forces are acting upwards, right? So this up arrow is also marked, so for easy identification in which direction this force is acting. Okay, so another force which is acting is at the center. Okay, that is P. Okay, so when in the calculations this forces are given a sign. Okay, okay, so the forces which is acting upwards are considered as positive. Okay, the forces which is acting downwards is considered as negative. Okay, so the when the downward force acts on a beam, so the supporting points okay, or the ends of the beam will take the load over the downward and equally distribute each other. Okay, so what I am trying to say is, okay, so whatever is the downward force, okay, the reactive force will be also equal. Okay, so for and this reactive force, the the summation of this reactive force will be equal to the downward force. Okay, so we can say, okay, reactive forces, okay, sum of reactive forces is equal to downward forces. Okay, so I hope till now you guys understood. Okay, so when we write all these forces in the form of an equation, okay, so what is the reactive forces here? R A, right, plus, okay, R B, right, RB, okay, is equal to what is the downward force here? That is P, right? So write it as P. So this is the equation, or this is the basic principle when we should keep it in mind when we are solving the SF and BM problems. Okay, so in other words, if I take this P to this left hand side, okay, what will happen? Reactive force plus reactive force A plus reactive force B minus P, okay, minus P is equal to 0. Okay, so from this thing we can come to an understanding. Okay, the summation of, okay, the summation of all the forces will give answer 0, right? So the to get that value, the summation and answer 0, you have to use the proper signs of the force. Okay, so this reactive forces are positive and the downward force is negative. Okay, when you are doing the summation of all the forces, you have to put the proper sign, then only you will get the answer 0. That is the another thing you should keep it in mind. Okay, okay, so so the statement I said is the summation, that is sigma. Okay, summation of all the forces is equal to 0, correct? Okay, now this also you guys understood, right? The both the reactive summation of reactive forces is equal to downward force. From this only we came to the formula, summation of all the forces is equal to 0. Okay, so let's assume let's give a number this as 1. Okay, now now uh, okay, so this formula I am writing in the next page. Okay, so RA plus RB is equal to P, that is 1. Okay, so in this diagram, okay, so we know the total length of the beam is L, so it is P is acting at the center, so A to C is L by 2, C to B is equal to L by 2. Okay, so now I am going to take a moment, okay, moment of the lever about the point A. Okay, so taking moment about A. Okay, so what is moment? Moment is equal to force into distance. Okay, that is the moment. Okay, so here the force acting on A is RA, right? And the distance between the point A and the force is equal to 0. Okay, that force is acting at the point A. So okay, so the moment at A will be R into distance. How much is the distance? Okay, that is it, since it is at the point A, distance is equal to 0. Okay, so at A is equal to RA into 0, correct? And what is the moment at point B? Okay, so the moment at point B will be, okay, R B, okay, into what is the distance between A and B, that is L, right? So that I will write L. Okay, so since this way RA and RB is positive, I will put the positive sign here. Okay, so this diagram, this formula only I am applying moment about the formula. Okay, from the point A. Okay, so is equal to, what is the at point C, the force acting is P, correct? So the point P and the distance of point P from A, that is L by 2, correct? So the sign of that will be negative since the force is negative, correct? So minus, okay, the moment the force will be P, right? And the distance from point A, right, that is L divided by 2, right? So from the previous equation we came to that all the forces are 0, so this also will be 0. Okay, so guys, this formula only I used here for taking moment of the forces. Okay, now we can we solve this equation? Since the Ra into 0 is 0, this will be 0. Okay, what is the remaining thing? Rb into L, right, minus P into L divided by 2 is equal to 0. Correct. Now if I take the minus PL into this side, then what will be there? RB into L is equal to P into L divided by 2. Okay, this L and this L cancels, right? So RB is equal to P divided by 2. What is RB? RB is the reactive force, right? So RB, the reactive force acting at the B, is half of the force acting downwards. Okay, that is what I told earlier slide. Okay, so let's give this as number 2. Okay, now we are substituting this RB is equal to P by 2 in this formula. Okay, so what will be coming, like Ra is equal to RB is P by 2, right? Ra plus P by 2 is equal to P, right? So Ra is equal to this P by 2 will go here, right? So P minus P by 2. Okay, P minus P half is equal to P half, right? So Ra is equal to P by 2. Okay, let's give it as number 3. So what is Ra here? Ra is the reactive force acting upwards. What is the value of Ra here? Half the force acting downwards. So this is the equation for, or this is the proof that reactive forces acting upwards is the summation of the downward force. Okay friends, from the previous derivation we derived Ra, the reactive force value of Ra is equal to P by 2 and reactive force Rb value is equal to P by 2. Okay, so now we are going to discuss something important called SF, shear force. Okay, so what is shear force? Okay, so shear force is the sum of the forces acting up and down at a point. Okay, so at the point A, okay, the forces acting is at the point A is P by 2, value is P by 2. At the point C it is P, right, the value which is acting downwards, okay, that is value P. Okay, that is negative, right? So at B the value is again P by 2. Okay, so the summation of all the forces acting at the point A, that is called SF. Okay, so SF is equal to SF at point A is equal to, what is the force, what are the forces acting at point A? Only the reactive force upwards. Okay, so that is plus P by 2, right? Now at point C there are two forces acting, right? So what are the two forces? Okay, one is the upward force from a point A. Okay, so and that is plus P by 2. Okay, another is the downward force acting from the load, that is minus P. Correct. So the value of SF at the point C is negative P by 2. Understood? Now you may be wondering why only we took P by 2 for adding with value P. Why not the entire upward force RA and RB together? Okay. So for doing this kind of calculation and for SF, so the reactive forces at a point, okay, so we'll the SF at a point, the our reactive forces will be considered from acting only from one side, okay, either from A to B, A to C, or from B to C, okay. So when I say point SF at point C, then the point acting downward at the point P and the reactive force before the point C, that is coming from A, that is P by 2, okay. Any reactive force after C, okay, then we will take this one of RB, okay. So now the SF at C, okay, so sorry, SF at B, okay. So at B, what is the shear force? Okay, it is the sum of all the forces acting at that point, okay. So at this point there is another 2 points acting, okay. So one is positive P by 2, okay. Other one is the downward force, which is from the carry forward downward force minus P by 2 from the point C, okay. So the SF at point C, point B is equal to the carry forward force from the point C plus the half force which is acting upward, okay. So the final value will be 0, okay. So the SF at one point B will be 0, okay. So finding this SF is not good enough, okay. So we need to draw a chart or diagram or graphical representation of how the SF is plotted, okay. So for that thing I will be using deleting some of this thing, okay. Okay, let's draw a straight line representing A and B, okay. So the positive forces will be plotted above, negative forces will be plotted below the line, okay. So this point is C, okay, where the load acting, okay. So SF at point A is positive P by 2, okay. So that is somewhere over here. Just assume this is the value and it is write as P by 2, okay. So this P by 2 will be continued throughout till the time another point shows up, okay. So at that point C, what is the value? That is negative P by 2, okay. So from positive P by 2 to it will straight away jump to negative P by 2, okay. So from P by 2, negative P by 2, that is from point C, it will continue till the time next point comes, okay. What is the next point here? That is B. What is the shearing force at B? That is 0. It will go to 0 level, okay. So this is how you draw the SF diagram of the uh, beam, okay. So that's all, my friends. There will be a worked out example I will solve in another video, okay.